Hi, I'm Carolyn Palmer, and today I'd like to talk with Alex Demos about analytical models of synchrony and entrainment in larger musical groups. We'll start with some terms. By synchrony, we're referring to the alignment of individuals' behaviors in time within the same sequence or time series. An example is musical ensemble members. Group synchrony can be intentional, as in most large ensembles, or unintentional, where there's no intention to synchronize or an intention to not synchronize, as in Steve Reich's phase shifting among musical parts. Entrainment usually refers to a coupling of rhythmic brain activity to external and internal rhythms. And we're going to focus today on the term coupling. Coupling usually refers to information shared between players, a mathematical function that describes precisely the interaction between the players, the groups, or the system parts. An example is how a performer's phase coupling describes how their beats are accelerated or decelerated by other performers. A famous example is Glenn Gould, Canadian pianist, who was interpreting the Brahms piano concerto at a much slower tempo when he played with the New York Philharmonic, led by Leonard Bernstein. As Bernstein put it, this was the Glenn Gould Brahms concerto, which asks the question, who is in charge of being the leader, the soloist or the conductor? And as Bernstein put it, usually it's a meeting of the minds, but in this case, the orchestra had to overcome normal coupling to perform correctly with the soloist. Now this is an extreme example. Most examples are more nuanced. So for example, this Schuberts octet starts with a single tone, an F major, that all of the 8 players have to perform together and to blend. But within the first 2 minutes, they reassume various combinations. So the clarinetist pairs with the cello and bass to carry the melody, while the strings bond and blend, and the horn and bassoon blend. About 15 to 30 seconds later, those subsets reform so that the clarinet is playing with the violins, while the viola, cello, and bass form a group, and the horn and bassoon form another group, and so on throughout the performance. Deckert provides a note-by-note analysis of this piece that's very interesting. But what this example shows is that coupling must be very flexible. Each performer has to engage and disengage within a few seconds with different players. And this is not limited to Western tonal music. We see it in many different styles and genres. So how do we measure synchrony, and in particular coupling, in these larger musical ensembles? Well, pairwise comparisons were the first approach in the smallest group, duets, and were based primarily on autocorrelations and cross-correlations at different lags between the performers. When the first larger ensembles were measured, pairwise comparisons were also applied to all possible pair members within the groups. Granger causality, transfer entropy, and relative phase were additional techniques. There are many advantages to pairwise comparisons. They permit comparison of how one pair behaves in a larger group context with how that pair behaves on its own in duets. And pairwise comparisons help identify asymmetries in influence between pair members. For instance, how pair member A influences B more than B influences A. There are limitations to pairwise comparisons when they're applied to larger groups. They assume equal access to information about each partner in order to generate some measure of coupling with each other partner in a larger group, which often exceeds perceptual and attentional capacities. Pairwise comparisons also assume additive influences of each partner or pair. They don't address 3-way or 4-way interactions seen in groups like these octets. So we look to other domains for guidance on how can we measure group synchrony in larger groups. 2 areas, social group dynamics and nonlinear dynamics, make predictions. In social group dynamics, team performance is studied across a wide array of goals and tasks. In nonlinear dynamics, coupled oscillators are analyzed across a wide array of timescales, from single cells or neurons up through groups or populations. So we'll start with social group dynamics. Group dynamics refers to understanding the patterns, roles, and structure of groups. And an important factor is group size. The increased size expands the number of interpersonal relationships per individual. And findings in social dynamics indicate that as the group size increases, the perceived self-contributions to the group behavior decrease, and the perceived self-workload decreases, sometimes referred to as social loafing. So think of a duet, a quartet, and an octet. The comparisons here indicate that group size alters the number of possible subgroups and their relationships to each other, those coupling terms. So if we combine group size and subset size, where group size refers to the total number of individuals in a group and subset size in the octet example here is 2 or 3, you can see that there's a trade-off between these factors. The group size and the subset size have an inverted U shape on the number of possible combinations that go beyond the realm of perceptual and attentional capacities. So what do group members do when they look to synchronize with others in the group? They could use the best odds to synchronize, or they could use strategies that reduce the number of comparisons. Another factor in social dynamics is group roles, that is, the tendency to behave or interact a certain way in a group context. Examples include task roles such as conductor or soloist that can change throughout the course of a performance. Findings here indicate that asymmetric influences of person A on person B increase as individuals assume roles. Roles can increase the predictability of the group members' behavior. They can increase the ease of coordination with other members. So consider a trio that has no roles versus a trio where there's a soloist and 2 accompanying parts. This raises implications for musical ensembles. Individual solo behavior may not be indicative of that individual's behavior in a group context. And another example is that leadership also needs some measure of followership. Not everyone can or is willing to follow. So there's a variety of group roles that might influence coupling. Group roles can reduce challenges. Consider the presence of a leader role, such as a conductor, that reduces the number of comparisons that performers must make to decide when or how to synchronize. So on the left is a graph of the number of possible pairwise comparisons that increases as the group size increases, shown in the black line. Consider when a leader is present in each pairwise comparison. The set of possible combination is now greatly reduced. On the right is the same graph but for n-wise comparisons, such as 3-sums or 4-sums. Again, the presence of a leader within each subset reduces greatly the number of possible comparisons that each performer must make to decide when to synchronize. There's a 10-fold reduction in the bars indicated in red on the left and a 100-fold reduction for the bars indicated in red on the right. So the point is that group roles may benefit larger groups more than they benefit smaller groups. Okay, so we've covered 2 factors in social group dynamics, and now I'd like to turn to what nonlinear dynamics has to say. And this refers to coupled oscillators. The Kuramoto model is the most popular nonlinear dynamical model based on weakly coupled oscillators that synchronize over time. And this famous example is of coupled oscillators that start by putting metronomes on a board of wood. They're all clicking at different phases, but because the wood allows the transfer of information between the oscillators, they are able to couple and reduce their phase over time. Same models have been applied to musical synchrony. So here's the model in the Kuramoto oscillator model for an individual oscillator. And what's important is the circled model parameters. So kappa is shown by the K. That refers to the coupling strength from one oscillator to another. And it's a function of the sign of the mean phase of the other members of a group. The group of oscillators is represented by this formula, which points again in the circle to the coupling term and the number or group size. So the circle on the right here you could think of as one musical beat, and each of the dots refers to a performer in the group. Their phase is scattered, so they're not perfectly synchronized. Over time, the Kuramoto model predicts that the oscillators will, with coupling, will force the synchronies to be more aligned. So the findings from nonlinear predictions for synchrony are that they're sensitive to group size in the number of oscillations and group mean, and to roles, kappa, or coupling between oscillations. A final point from the nonlinear dynamics, it refers to emergent behaviors, interactions among oscillators that arise from unique or nonlinear parameter combinations. So consider an uncoupled trio, like a bass, a guitar, and drums. Perhaps they're all playing, but at different tempi, because they aren't trying to, or perhaps can't hear each other in order to synchronize. We can plot the model parameter predictions, in this case for tempo, where G, B, and D refer to the intrinsic frequencies, or tempi, of these different performers. The amount of energy that it takes to change tempo is shown on the y-axis, and you can see that it takes quite an amount of change in energy for one performer to shift to the tempo of another performer. Now let's take that same group and couple them so they can hear each other and they are playing together. So here the pattern shows a new model parameter, the energy of the trio, at one point, and it's a function of the other three intrinsic frequencies of the performers, but it's a non-linear function. So the energy required for each of those performers to shift to the trio rate or tempo is much smaller now. So where does this leave us? We think there are some proposals we can make for going forward in musical group synchrony applied to larger ensembles. First, we would apply individual synchrony indices of how likely performers are to assume group roles in order to predict asymmetric coupling between them with others in the group. Second, we would apply a group synchrony index that incorporates group size and subset sizes in order to predict how that changes with the size of the subsets. Some of these metrics already exist. Finally, we would examine group desynchrony, both intentional and unintentional, to try to predict how people desynchronize at transition points of weakened coupling. So I'd like to take this opportunity to thank the organizers, and I look forward to your questions.
Thank you so much for that wonderful presentation. I'm wondering if anyone in the audience would like to start the questions. And, oh, sorry. Oh, I see there's a question from Laura Bishop coming right to you.
Hi. So I'm wondering about leadership in the case of an orchestra and the role that the conductor has in the moment of a performance. How would you go about mathematically and reliably distinguishing between what is practiced, leading and lagging between the conductor and the musicians, and kind of leadership that's emergent in the moment? So I guess quantifying how much effect the conductor is actually having during a performance and distinguishing this from the practiced relationship that they've had with the orchestra.
That's a great question, Laura. There's a lot of parts to it. So we only have some information for some parts of your question. So I'll start with the inverted U-shaped relationship between the group subset size. So let's say the string section or the first violins, right? And the total group size, the entire orchestra. So I think you could actually make predictions about the interaction between the subsection in which a particular performer was and the total group size of the orchestra to tease apart how many people could be coupling at the same time. But you raised some other issues that we have less information on, I think, like what information in their practicing do they bring to the group performance that influences the hierarchical relationships? And that's where we've been interested in using the social group dynamics to get a better measure of, for each individual, how likely are they to assume certain roles? Are they happy being one in a set of 10 in a group? Or are they better adapted to being just 2 of 3 percussionists? So I think if we use different methods, we could tease apart these factors better.
Okay, thank you.
And a question coming in from Finn Upham.
Hello. Really interesting question. I mean, that you're tackling, not about me. That's you get to choose how you feel about that. Thinking about the experience of playing in ensembles, particularly in ensembles with different instruments in play, the opportunities to influence each other really depends on the part that you're playing. And so I'm wondering how you're thinking about parts in their arrangements for the kind of influence that's possible. I've been in a lot of ensembles where, as somebody who plays in the bass range, my opportunities to influence the group varies a lot because I don't always get a lot of onsets. So, how are you thinking about the music's contribution for the opportunity for leadership, and then the sort of consequences socially about who gets to play what, when that is partially determined by what you play physically rather than who you are in other domains? Thank you.
Thank you. That is a great set of questions, Finn. So we chose the octet on purpose because the composition, the rhythms in the parts of the composition, lended itself to ensemble members having to repair with different groups of ensemble members. So certainly we would have to acknowledge that the musical composition and the rhythms involved are going to influence who's having to bond with whom. But at the same time, I would say many non-compositional forms show that same kind of repairing of individuals. So for instance, improvisational jazz. Do we know how much success they have resynchronizing in these different genres? Probably not yet. There's some really nice work on improvisational jazz among small ensembles. I haven't seen as many studies on large ensembles, so you might have some suggestions for that. Thank you.
And thank you so much, Carolyn. Are there any final remarks or questions? Okay, in the sake of time, we're actually just going to move on to Alexander Demos' talk. So we will see you, Alexander, in just one moment. Well done. Thank you.